All right. There's plenty of seats down front if anyone wants a seat and doesn't have one. And thank you all for showing up. I am blown away by the number of people who have shown up to this session. Containers and Kubernetes 3 years ago at Seattle was not nearly this popular. So thank you all for making that happen. My name is Bob Kuszewski. I'm a product manager on the data platforms team. I know I've worked with a number of you on various things in the past, and those of you who I haven't worked with, hello and welcome. Nice meeting you. With me today, we have Kai Zhu, who's one of the development managers on our newly renamed platform engineering team. I just learned that yesterday. It used to be called release engineering, but they have a new name. We have Ari Glikman, who's one of our sales engineers, who's been doing a lot of work in Kubernetes. And we have Mark Bolinsky, who many of you probably know is one of our architects, and you manage the I don't know. You do something. I don't know. He does stuff. It's complicated. So today we're going to be talking about a number of updates in the containers and Kubernetes world, right? We have Kai will be talking about the post-release container image refreshes. So this is something we've been doing since January that we're waiting to announce until Summit. I'm very excited to announce this because I think it's going to make your lives easier for all of you who are using containers. Mark is going to talk about a number of common deployment patterns for containers, for Kubernetes, and Iris. And Ari is going to talk a lot about IKO and Kubernetes in specific and some of the lessons that you've learned and get you thinking in the right way to be successful with this. And that's it. That's my job is now done until the end. So this is the easiest session for me today, and thank you all for that. So onward over to you, Kai.
Okay. All right, thanks, Bob. I have no idea how this works. Right and left. Okay. All right, so let's talk a bit. Can you guys hear me fine? Okay. Yeah, the post-release container image refresh process here. So as many of you may have already known, in addition to the regular kits that you download and then install, there's also the container image kits that we offer. But prior to this process here, our images only get updated as part of the release process, and they remain pretty much unchanged after that version reaches general availability. So here comes the problem. The OS packages in those images have their vulnerabilities exposed in a continuing way. So to keep up to date with the fixes of those, we've designed this new process to just keep refreshing them in our images. So the general idea is to keep refreshing those OS packages in our container images while also making sure that the InterSystems product installed there remains the same. So to make that easier for us, and more importantly, to make it easier for you to get the updates, we've started with Iris 23.2 general availability from last year. We've introduced a new way of tagging these images. We have the major.minor tags replacing the full version tag that we used to have. So with this, you can easily get the updates like the extended maintenance release or any other kind of refreshes that we have here. In addition to those, we also have a bunch of latest tags for different streams that we have here. So with the help of these new tags, internally we would refresh our images twice each week. And then once every week, we have a process to publish the validated images to our InterSystems container registry. So one thing I would like to point out about these images are some of the labels that we have here, specifically this 4 that I've shown here, that gives you like version and timestamp information. So if you look at the image version here, you'll see that there's a -1 at the end. So that tells me that this is actually the first respin or refresh of this exact image. And then from both the image version and the product version, you can see that's actually Iris 24.1 release that we had released a while ago. And then the image timestamp tells me that this specific image was built on May 15th, but actually installed with the product that was built on April 30th. So how's this done? It's pretty straightforward, actually, because we've automated the whole process internally, starting with the build step that calls out to like Docker build or Podman build. Again, as mentioned, it'll be using the exact same product that was used in the corresponding GA release. And then we run some automated tests, as well as some security scans. And then once each week, we have a process to post them to our InterSystems container registry. And that's pretty much it. So thanks for your time. Next up, Mark will talk about the deploying models.
I'm sure I probably have talked with a large majority of you in the past when it comes to deployment models. When it comes to configurations that go out the door usually come through me. So a lot of times you'll see my stamp on a lot of these things that go out. So what we'll do is we'll go through, did I go the wrong way? There. I'm going to show you 3 different flavors of a deployment. Here's an example using AKS. So it's Azure's or Microsoft Azure's flavor of Kubernetes. Now, you look at this as quite an eye chart. There's a whole lot of stuff going on here. It can be boiled down to a very simple deployment. But what I wanted to show here is we're often asked, well, how can I horizontally scale my interoperability production? So I have a large number of HL7 interfaces. I want to be able to horizontally scale these. Well, it's one of those scenarios of it depends. It's complicated. It really does depend. A couple of things that factor into that. One is FIFO. So any kind of HL7 messaging that you're doing, you're going to require FIFO, and there needs to be a one-to-one affinity for that inbound interface to go through any kind of production. But you can spread those out. So you no longer need to have one container or one instance handling your entire production. So you can say, I want this HL7 interface going here, another one goes to another pod, and you can scale them out independently that way. So if there happens to be an interface that requires more resources than another, you can assign it different resources within that pod to handle that workload. And then you can scale those pods as needed across more nodes. So you can collapse these down. So if you say a minimum of 3 AKS nodes, you can potentially have, your minimum would be 3, but if you need to scale out, say you have 10, 20, 40, 100 pods running, you can elastically scale out your AKS nodes and the pods get scheduled out further across them. And then as your workload diminishes, it can shrink back down. But again, you still have to have that affinity because of FIFO. Now, when it comes to other things that may be REST-based, CCDAs, for example, or FHIR, anything that doesn't have that forced affinity, you can then do an active-active type model. And typically, you can spread that out. So you'll see here on the left, I have 3 different ingress controllers. So one for each of your different HL7 interfaces. And down on the bottom left, you'll see one there called the HTTPS ingress controller. The reason why I have them split out and not all going through one ingress controller, because I want to control as to what goes where. Within the ingress controller, it's going to talk to your service name. So on the bottom, we have the HTTPS that's coming in. It's going to communicate with the name service that will be load balanced active across n number of web gateways, which will then go to whatever corresponding IRS for health instance. And then you have all your normal Kubernetes storage class behind it. Here, we typically like to use the premium V2 within Azure. You can also have Azure files or Azure NetApp files behind it if you need any kind of NFS, CIFS, type access, or SMB. But if we move up to the ingress controllers that are HL7 based, and the reason why we want to have these isolated, because you want to have these associated to different Iris deployments, or mirror pairs in this case. And the way our IKO works and the way our mirroring works, it's all controlled through pod labeling. And so that way we can control that HL7 messaging always goes to the right mirror member. And so if you're splitting your HL7 messages across multiple pods, you want to have multiple ingress controllers to do that. There might be other ways to do this, but this seems to be the simplest. So then we'll give you, if there's any glaring questions, we do have Q&A at the end, but if there's something you absolutely need to ask me, feel free to raise your hand. I'm more than happy. For those in the back, there's a few seats up front if you want to sit, or if you're happy standing, that's fine as well, but we won't bite. I can't speak for Bob. So, here's an example using EKS. This is an example using our track care, our EMR, basically. So it's using, there's two different ways you can go about this. One is using two different EKS clusters. One that's going to be for your persistent tier. So I'll work from the bottom up here. So we'll kind of go on the opposite. So EKS cluster number 2, that's on the bottom, that's going to be our persistent tier. And usually you're going to have fixed resources allocated to that. And then you're going to have your ECP servers that are going to be operating within that. Then you can have up to EKS cluster number 1. These are things that are going to be elastic, ephemeral, where you want them to grow and shrink based on demand. And the reason why I have it split into 2 different clusters is it makes it easier to do that. Yes, you can do it within a single monolithic EKS cluster, and it's even heterogeneous where you can have different sized nodes. So if, say, for example, you have a 5-node cluster, you can say 2 of them are this big, you know, maybe 16 or 32 CPUs, but the other 3 are maybe smaller at 4 or 8. And then using pod scheduling rules, you can assign them to go there. I just like having the isolation between them, but you can do it 2 different ways. The benefit here with using the cluster number 1 on the top for that horizontal scaling elasticity is then using cloud to what it's actually meant for is you're only paying for the resources you're using at that point in time. So cloud becomes cheap when you can turn things off. And only using and bursting when you need to. That's where EKS becomes, and the elasticity becomes very important. I'm showing a lot of diagrams and boxes in here, but basically we're using the EC2 container registry. It's hooked in with the EKS cluster, and you can auto scale those groups out as needed. And just, you know, because I love my HA and resiliency hat, I have these spread across 3 different availability zones. Now, when it comes to your storage classes, here I'm just using straight up vanilla GP3, but there are a lot of, I'll call them distributed storages or CSI drivers from third parties that, you know, Portworx volumes, Trident, there's a whole host of, yeah, there's tons of them. We don't, I'll say explicitly validate or endorse any one of them. Just as long as they work with Kubernetes, we don't care, and it meets your performance profile. And then here's another one. So this one is not Kubernetes. Did I go the wrong way? Oh, no, I'm good. This one is not, oops, sorry, I pressed it on my lap. Ah, jeez. Okay, there we go. So this one is not Kubernetes based, but it is still container based. So compared to the first or the prior diagram, on the bottom tier, instead of using Kubernetes, I'm just using straight up EC2 instances because I know it's a fixed workload. I need it. It's going to be persistent. It's going to be there all the time. So might as well throw out an EC2 instance. I want to put it in Docker. Sure, you can certainly do that. You can have Docker in there if you want everything still managed and maintained by a container. You can certainly do that. You don't have to, so you have the freedom of choice. Now, in the upper tier, you'll notice that this is ECS, which is the Elastic Container Service, not the Kubernetes service. The difference between the two really is this allows you to get down to 0 scaling, where EKS, to provision EKS cluster, and the to deploy it, use it, and then tear it down, there's a lot of overhead. There's a lot of time that comes with that. Unlike ECS, basically, you put it in an auto-scale group. You can scale down to 0 if you want, and it just calls out to the container registry, grabs the container. It'll be a pre-built image. So in the case, again, we're using TrackCare as our EMR as the example here. We just allocate more print servers, more application servers, more web servers, whatever we need, we just add them there. And the beauty on that is it scales down to 0. So there's just three of them, many different ways you can do it. I didn't cover anything that would be more on-prem. So if you're talking, VMware's Tanzu or OpenShift or anything like that, they're all possibilities. We're actually considering looking at some of those as well for our own private cloud. Haven't decided on one yet, but if there's questions at the end, I'm certainly happy. Now turn it over to Ari.
Hello? Okay. I think I'll stand up since I'm too short otherwise. Okay. So over the last year and a half in Israel, we've been going really strong on cloud deployments, whether it be private clouds, hybrid, public clouds. People will also be doing, as Mark mentioned, they'll have their Tanzu Kubernetes deployments or OpenShift and stuff like that. So they like these self-managed clusters. It's kind of a slower transition into them, as opposed to the ones that we manage, the managed clusters, which are also an option. And with the self-managed clusters, there's a bigger of a learning curve, okay? So there's a lot of clients that will stumble in lots of different ways because there's a lot of stuff that they're taking responsibility for. And so my job as an SE is to help them out with that transition to their Kubernetes deployment. And I want to kind of show you some of the things that they've had some troubles on. So first and foremost, and this is a shot at any Sixers fans maybe here, is we have to trust the process, okay? So what this means is we're going to be deploying, I like to have a script to set up my environment before I deploy what's called my CRD. We'll get into that. But first, we're going to create what's called a pull secret. So this is for if we're pulling, from the InterSystems container registry. Maybe we're pulling from the ECR, Quay, any registry you're using, whether it be GitLab or whatever. We're going to create, if it's a private registry, we need to have some kind of pull secret that's going to authorize and identify us when we're pulling our image from there. Then we're going to need to install the IKO. So this is with a Helm chart, okay? That Helm chart, one thing to note is that we need to actually download that from software distribution on the WRC. So the images are all available on the ICR, but the Helm chart, okay, and all the folders and things that come along with it, we're going to need to download that from the WRC. Then we can set up any config maps and iris secrets, so maybe that's the license key or other things like that, okay? And then we're going to deploy our CRD. So the CRD is the meat, okay? So this is what we're actually deploying when we're saying I want my iris application to be such and such. This is our topology, and we'll talk a lot more about that. And then finally, any final resources we want to be creating. So maybe we have some sidecars. We need to go ahead and create some services for the sidecars. Maybe we want to set up Ingress, as Mark talked about. That's another option. Okay. So I mentioned the IKO, and we have to install it via Helm. So Helm is the package manager. It's what IPM is to InterSystems, so the InterSystems package manager. Helm is for Kubernetes, okay? So it does the same job, and with when we're downloading, we're going to download this kit from WRC software distribution. We're going to get this kind of folder structure that looks like this. And you'll notice we have this folder called the templates folder. And in the templates folder is a bunch of blueprints, okay? So we don't need to go inside those blueprints and play around with them, but they're going to be able to take configurable things from what we're going to see in our values.yaml on the next slide. In this templates, we're going to have blueprints for the deployment, the service account, roles, role bindings, webhook secrets, and services, okay? So, you don't need to use the IKO, the operator, if you want to deploy on Kubernetes, but otherwise you're going to have to be in charge of deploying all these resources. So it's really recommended, okay? You shouldn't be deploying in Kubernetes without the IKO. In this Helm chart, in this package, that we're going to download from the WRC, we're also going to get an image, okay? So this is the same image you see in the ICR. And then we're going to get a sample. So this is going to be some sample YAMLing, some really vanilla kind of, for getting started on how to use the CRD and deploy with it. Okay, so in the values.yaml I mentioned, so I've had some clients that say to me, I'm using, instead of ARM, I'm using AMD, or instead of AMD, I'm using ARM. So we can actually set up what kind of node and processor we're running on here. Okay, we can, set up the CA certificate. We can decide whether we want to create a service account or not. So in here, if we want to, set something for our operator, it's going to be in the values.yaml. So that's something important. That's something clients will often say to me, I don't know, what am I supposed to put in the template? So no, you shouldn't be touching the templates. We want to go into that values.yaml and work through there. Okay, so I brought some Lego that I want to really drive this point home through, is that the IKO and the CRD that we're building is really, you can plug things in and you can take things out as we wish. So first and foremost, I like to start with, the simplest is going to be just a data node. Okay, so this is just going to be our Iris for Health, our Iris maybe it's just HealthShare Health Connect, whatever it be. So we're going to start with a data node that's going to be our main image. But as you may know, as of 2023, thanks Bob, as of 2023.2, we don't have a private web server that comes along with it. So we need to go ahead and plug in a separate pod. And that second pod is going to be able to give us access. It's going to be that web gateway, whether it be Apache, Nginx, okay? It's going to be that, that kind of pod that's going to help us access, okay, the management portal. Thanks. Next, maybe we want to add some mirroring, okay? And if we're adding mirroring, we certainly have an arbiter. Okay, so we can set that up too. And it's just as easy as setting a certain value in the YAML. So you have this all in the C event app, and it'll all be published. So don't feel the need to be, squinting too much. But we have the option to just in our YAML say, mirroring true, mirroring false. It makes it really easy for us. And so that's the magic of the IKO, the whole scalability part of it. Let's do another. Now, if we're having mirroring and we're having an arbiter, what we need to be having is a sidecar. The sidecar is what's going to give us access to a certain pod in particular, okay? To a certain container in that pod. So now we're putting multiple containers in the same pod. We're having a sidecar to be able to access a specific, maybe we want to get into the backup, but the main web gateway is only going to get us to the primary, okay? So that's what we need the sidecar for, and for the arbiter to be able to communicate with both instances if we have mirroring. Maybe we want to add compute nodes. So I have a client, they say to me, oh, in the busier period, I want more compute nodes, or in the less busy period, I want less compute nodes. So it's just as easy as in the replicas scaling, whether we want 1, or we want 2, or we want 3, or we want lots more. So we can also add compute nodes and sidecars for the compute nodes as well. Perfect. And now, as Mark mentioned, we can have different types of volumes, okay? So we can have, through our storage class, we don't have one that we specifically endorse. We can have different volumes, so we can have one type of volume, and then when we add another volume, it can be of a different type. So and this is not just size, this is again storage class, okay? So we can have one that's, made for a specific AWS storage class, and we have one that's made for a different, customized storage class or whatever it be. So depending on what kind of volume we want, whether this is for our predefined persistent volumes or for the ones that you want to mount that are part of your application also. And lastly, we have the option to add IAM, so our Kong web gateway if we want, and it's just as easy as a few lines in the YAML, so the IKO is going to make that really easy for us. And then maybe we want to add some configuration files as well, okay? So just as easy as we built it up, we can also take it down. And that's kind of the point I wanna really drive home, is that we can plug and play with any parts that we want, and use that to however we want, whether we want mirroring, we don't want mirroring, and stuff like that. So at least in your CPF file, so we can set it up whether it be for the data side, the compute side, or just in common in general. But we at least need to set up a password hash, which is what we see here. Okay, so I mentioned also that we have some sidecars. So in order to access those sidecars, what's exposing them is what's called the service. So a service is going to expose a pod. So we can have a sidecar for the compute, we can have a sidecar for the data nodes, and we're going to expose them to the whatever network it is we're working on via a service. A service is going to expose a pod. there's these things called labels, okay? And via the selector, so in here we have a selector in the definition of the service, and via the selector, it's gonna go and look at whatever label a pod has, and it's gonna say, okay, I want to expose this pod with this label, and I do that via this selector, okay? It's kind of like a name or an ID for each pod. So with a service, we can expose, the sidecar of the web gateway in a certain data node. Maybe we want to see what's going on with the backup, so we can do that. There's another step or a layer that we can add to this. Maybe we don't want to be accessing each service individually, but we want to use, access them all together. So as Mark mentioned, we can add what's called ingress. Ingress gives us the option to have all service and traffic, although you can have multiple ingress controllers, as Mark mentioned. A simpler idea is to have one ingress controller, all traffic goes there, and then we have in the ingress, we have path-based routing, okay? So there's all sorts of flavors for ingress controllers. There's Nginx is a common one, but there's, Kong has their own one. There's lots. AWS had their own one. There's lots of ingress controllers, and we can go ahead and configure that also, if you want to figure some timeouts or cookies or stuff like that. And then the ingress via the path-based routing is going to go and select a certain service for us. Okay, going back to storage classes. So we can go ahead and define storage class either for all of our predefined persistent volumes that when we're deploying our IKO, our CRD, or we can define it for each individual predefined persistent volume. So I had a client that was saying to me, I don't know why, but I'm having an issue because it's grabbing the wrong storage class when it's creating the persistent volumes. And so we looked into it, and they hadn't defined any storage class name in the IKO. And so what was going on in the CRD? And so what was going on is that when we don't define it, we take what's called the default storage class, okay? So in every Kubernetes cluster, you'll have a default storage class, and you don't want to be switching which is the default storage class because maybe there's other things that are already dependent on that default storage class. So instead of switching the default storage class, we just want to go ahead and specify, whether it be at the persistent volume level or at the whole Iris cluster level, we can go ahead and define which storage class we want to be using, and here on the left you see an option for a EBS storage class, okay? And this is just from the AWS docs. Okay, recently I've had a couple clients that have come to me and said, I had previously on my on-prem, I was working with huge pages. How do I do that in Kubernetes? So this is very possible and it's very doable, but we have a little bit of a different process for it. Okay, so first things first, our pods are running in nodes, okay? So we have to make sure that there's huge pages available at the node level, okay? So we have to go ahead and enable huge pages at the node level. Then what we need to do is actually change a little bit what the image definition is, okay? So our ICR image that we're pulling, whether it be Iris Health, Iris, whatever it be, comes without this IPC log capability at the moment, okay? And so we need to go ahead and in a Docker file redefine or add this capability. And this isn't just for huge pages. So I had another client that wanted to encrypt their database, okay? So to encrypt their data at rest. And we wanted to use KMS, so the AWS Key Management Service. And what we needed to do there was add the AWS CLI into the image, because you don't want to be installing it in the container itself, because then it's not persistent. Then when the container dies and it restarts, you're not going to have that AWS CLI still on there, okay? So what we want to do is in the Docker file, go ahead and set that up and install it at the image level. So every time we pull that image, okay, and we're going to get those same capabilities we had. So it's really important, and that's a good point to drive home, that we can actually play around and add and configure however we want and what we want. So Kubernetes really gives us a lot more room to play and room to wiggle to configure things exactly how we want them and make it, scalable and very easily configurable. Then at the bottom, we see in our YAML definition, we can add whether it be, you have to check with your your cloud provider what huge pages are available, because again, not all cloud providers are going to support all huge pages or huge pages at all. So you have to go ahead and check which cloud provider you're using and what they support. And then we can have, if this one supports 2 megabyte size huge pages, how much we want, something like that. Now you'll notice we also have what's called requests and limits in the resources, and this is going to allow for what's called guaranteed quality of service. So we have what's called quality of service, which is when there's a lot of workload on the nodes. It's going to have to say, I need to cut down on these nodes. I need to trim them down. And what's happening is it's going to look and say, okay, what's the least important nodes or what's the least important pods that I have? And we want to, our critical applications like Iris, we don't want that to just be, oh, I need some room. I want to get rid of Iris. You don't want to take that down. So what we want to do is make sure Iris gets what's called the guaranteed quality of service. And in order to do that, we need to set the requests and the limits to be identical. Okay, so that's to get, again, the guaranteed quality of service. There's other lower classes for quality of service. And this is an example of just a simple Docker file that we can add the IPC log capabilities. You can also add, I added with a client a couple weeks ago the AWS CLI. We can add all sorts of things. Clients will come and also say to us, which cloud provider are you suggesting for Kubernetes deployments? What about EKS? There's AKS, there's GKE. So all of them have the K. All of them are for Kubernetes. And at the end of the day, we're agnostic. Okay, we're running on Kubernetes. We're not running on Google. We're not running on Amazon. We're running in a Kubernetes environment here. Okay, so we don't endorse any of these. We can use all of them just as well. Now, what is important to note is that there's other things. So Mark mentioned OpenShift, which is the Red Hat's container platform. Or Kubernetes platform. And then OpenShift, they actually went a little bit further and they extended what I would call the Kubernetes definition. Okay, so in OpenShift, they have this concept called the security context constraint, which is not something that's defined in Kubernetes, but it is defined in OpenShift. And we were having issues with this client that wanted to deploy an OpenShift because they were getting issues, first of all, that said, you're running as root. And as of our latest images, Iris is not running as root, okay? But there is some init containers that run as root. And on top of that, we have to also allow the Iris user to run because they hadn't, in their environment, in their Kubernetes cluster, in OpenShift, they hadn't set up the Iris user, the Iris owner, okay, so 51773, to be enabled to create or delete or write to things, okay? So we needed to, first of all, enable that user. And then second of all, in the IKO, in the CRD, okay, what we needed to do was make sure our init containers, which are created before the main Iris container starts, we need to go ahead and make sure that those were running not as root. For historical reasons, sometimes they'll run as root, okay? But we can go ahead and also configure that. So again, the CRD and the CRD is going to give us a lot of of wiggle room for what we want to be doing, and we want to make sure that we're matching it for our needs in our cluster. A couple last things that I wanted to talk about were lifecycle hooks. Okay, so there's two types of lifecycle hooks that we can use in our CRD, and this is at the pod level. We can use what's called the pre-stop lifecycle hook, and we can use the post-start lifecycle hook, and these are things that are defined in Kubernetes. The pre-stop lifecycle hook is really useful because maybe someone's going to kill a pod, but before that pod is killed, you want to make sure Iris stops safely. Okay, so here you see an example of how you could do that. So it'll make sure before this pod is stopped or restarted or killed or whatever it be, we're going to go ahead and stop Iris. Another option that lots of clients will ask me about is the post-start. I want when Iris starts, I want Iris to start in with some command at the beginning. The issue with this is that the post-start lifecycle hooks per Kubernetes does not guarantee order of execution, okay? And we need Iris to first of all be started first. So I wouldn't recommend using the post-start lifecycle hook if you're dependent on that order of execution. That's something important to note, and that I'll see clients struggle with. That's not the way to do that. So if you're looking to do that, we can talk about that later. Mark and I are going to be doing tomorrow a tech exchange where we're going to be getting our hands a little bit dirtier in Kubernetes deployment. So to anyone that's interested in getting more into the Kubernetes world, then we're happy to have you. The last thing I want to talk about is TLS. So we talked about encrypting data at rest, but you should also be encrypting data in transit, okay? And we do that via TLS. There's two types of TLS that the CRD is going to provide for us. We can have what's, a common TLS, so encrypt all data in transit via this common secret. Or we can have, per component, per type of communication. So maybe I want different TLS between my web gateway, my mirroring, and then, for the rest, I can define a common TLS type. And it doesn't even have to be it can be when you're defining the TLS secret, okay? The secret you can grab and create from local files that you have in your Kubernetes, environment that you have accessible to you on your command line. But you can also go ahead and take them from a CSI volume, and that's what we see here for the mirrored CSI TLS encryption. So that's everything. I'll hand it off back to Bob to summarize.
All right, thank you so much for that. All right, so a number of you kind of came in a little bit late. You may have missed the announcement at the beginning that Kai did. We have, for all of this year, been updating all of the Iris containers that are in they're tagged with the year and release. So the 2024.1 container or the 2023.3 container that are on our container registry. We've been updating them with the latest, greatest version of the operating system and all of our third-party dependent components on a weekly basis. So if you are scanning our containers and saying, oh man, how do we keep up to date with the infinite variety and never-ending list of known vulnerabilities, this is an important tool for that. So you could get into a habit of grabbing the latest version of the container every week. It's the same tag, so you don't have to do anything different. You just grab the latest version. Mark talked about common deployment patterns. There's lots of information on that I'm sure that just scratched the surface on. We did do a whole session last summit, or was that 2 summits ago? I think it was last summit, that on horizontal scaling of stateful workloads. And of course, Ari, thank you so much for talking through all the Kubernetes deployment patterns and getting started there. What's left for me is to say thank you. There's a survey in your Cvent app that we're all going to be asking you at the end of every session to fill out. Your answer is, this was a 5-star session. It goes up to 5, right? I don't know. I haven't looked. No, whatever. We appreciate your feedback. Certainly, this is how we get better year after year, and I appreciate that. We also have early access. Oh, hold on. I forgot my most important thing here. Come see Ari and Mark at the Tech Exchange if you have questions. You can see them live in person. Ask them lots of questions tomorrow at 2:45. All right. We also have early access programs. You're going to see this slide a lot. None of these apply to this particular topic, but I'm not going to say no to people joining. So it's just time for questions and answers. Does anyone have any questions? Dimitri?
That was a good idea about updating images, but with current tagging, so latest, not clear enough. I would like to see on ECR UI what exactly the version behind the tag, full tag, full version, and also timestamp. So I would just go there, without pulling it, I would just see what is exactly there.
Okay. I'm not sure that's a question, but thanks for the feedback, right? I appreciate it. There are some things to the container registry UI that we're kind of considering and thinking about, looking at. Any other questions? Yeah.
Thanks for the presentation. Is it possible using service mesh solutions like Istio or Cilium for offloading the TLS between pods communication, for instance?
Yeah, so we do have clients in Israel that are using the Istio service mesh, so it is possible, yeah.
you guys have a pattern for like cross-region global deployment?
Sometimes.
For cross-region, it's one of those it depends scenarios. Depends on the access pattern, depends on the data. How up to date does the data, so if you're replicating data between regions, is it eventually consistent data, or does it need to be real-time consistent data? So short answer is yes, maybe, maybe not. But yeah, if you have a specific scenario in mind, I'd love to talk to you more about it.
I believe that Sam, are you doing a demo of the cross-region? No, never mind.
Yep.
I'm not sure what I'm allowed to talk about yet. Sorry about that. Who else?
Yeah, hi. It's just a quick question. So we have InterSystems is hosting our solution, under managed services, and I just wondered if I'm not aware that they're using Kubernetes under the covers, but maybe they are. Or they have plans. Anybody know anything about that?
Which managed service? Which application?
We have both. We have several environments. We have Iris, HealthShare, and and then all.
More than likely, it's not. Because it is a service, probably doesn't matter to you, kind of thing. But that is a direction we are heading with all of our products, actually, is to get to that, because there's efficiencies there in hardware expenditures and whatnot. So,
okay.
Short answer is, yeah, we'll get there.
Okay. Okay. Good to know. Thank you.
Anyone else?
So is this, the containerization stuff, is it available for like all the different InterSystems pieces of software? So like we run Unified Care Records, so I don't know, is that one in particular that you guys are laughing? This is not reassuring. Okay.
There's a ringer on that.
Sorry.
So let me preface it by saying, yes, all of our products are container-based. Getting it to a Kubernetes state there's a little bit of legwork yet to do on the UCR front, yeah. But it is planned.
Like timeline? Eventually?
Let me get back. Yes, eventually. I mean, don't hold me to this, but I'd say within the year. I mean, timelines slip on everything with other priorities and whatnot, but I'd say by this time next year, hopefully I'm doing a session on UCR and Kubernetes. Sure.
Is it a question, Dimitri? What questions are?
Okay. Very interesting question about any strategic about how to be safe of OM killer.
In Kubernetes, yeah. So Kubernetes, this is an interesting one. So Ari touched on it earlier about the your guaranteed performance, your guaranteed availability. And this is where it becomes very important, especially in Kubernetes, because if you launch another pod that has more resources that's available to it and at the actual node, it will evict another pod to schedule now and run this pod. So you need to be very careful. Now there's switches you can set to prevent that from happening, where we treat the Iris pods as basically system level pods that it won't. The use of huge pages become also important, especially in Kubernetes. Now, Ari touched on the subject, so GKE as an example, not to pick on them, it's just GKE is one of the platforms that does not support huge pages. So when you plan a deployment on GKE, you have to account for not only your shared memory segment, all your processes running, but then also what are called the page table entries, your PTE overhead, and also your swap reservation. Even though we always size to never swap the system, Linux in all of its glory says, well, this is a side effect of Kubernetes. Kubernetes currently does not support a swap file at all. And we never size to swap, but because there's no swap file present, Linux decides to say, well, I still need to make the swap reservation, so I make it in memory. So you need to be very careful in planning your memory allocation. So if you need 32 gigabytes for global buffers, for example, you need to make sure you're doubling that at least in Kubernetes, just so you don't.
In GK specifically,
Yes.
yeah. Kubernetes is working on
It's in beta
swapping. It's in beta, so it's real close, and certainly beta things in Kubernetes are all basically usable. That's it for time. If you have questions, you have more things, I'll be here afterwards, as will the rest of our panel. I've already advertised for Ari and Mark. So thank you all very much. I appreciate it.